Thank you very much.
that I not read this. Yeah, right. Thank you for
No, thank you,
telling
doctor.
me. Do not hesitate to tell me, because I tend to forget this. So it has happened once, but I hope that it won't happen again. So do you see my browser? Have my other screen that went away.
Yes, we can see it, doctor.
Yes, you can see it. Okay. So here you have the creation of the graph. So the idea is that we have students and we have courses and we have projects and rooms. So students are inscribed in courses. They also are involved in projects. Courses take place in rooms. And what else? Yes, and the students work on projects during a specific number of hours. Okay, so that's the simple graph that we are going to query. So first thing, well, you can copy. I'm going to copy the specification of the graph. So. Okay. And so, well, you should have, I was playing with Aurora before. In Aurora, well, what you do is you paste and you execute and you wait for a little while. And at some point we will have where we stopped last time. So last time I had my soup of notes. This time my database is clean, so I'm creating from scratch the graph. And I really hope that today I'm having really enormous connection problems. So I hope that this will work. Okay. So I let you from your side do the same, and let's wait for a while. I shouldn't have deleted the database, but I did, so we have to wait for a while. If you finish, tell me, and we can move on, even if my system is kind of sleeping for a while. So just raise your hands or tell me when you are done with the creation of the database, so that we can go forward into the queries. So while this is, and I have an error, of course, because I have a problem with the copy. I tried this today. So I'm going to do it partially. What did it do? Sorry, I'm going to stop sharing to see what I'm doing. If you have problems, copy pieces of this, because of course there are weird characters in the what I'm doing. I'm going to stop sharing, and I'm going to have this. Okay. So now, yeah, this is good news. It didn't create everything, so that's great, because I'm going to create first the notes. Just give me a second. As I said, if you finish before myself, raise your hands, and do not hesitate to I'm waiting. So try to create, yes, to avoid this stupid thing that I did, that I copy everything and I have this problem. You can copy pieces and do not have your problems. Right. I am going on. So I'm going to do my copy paste on my side, and then I restart sharing my screen so that I can show you. No. Right, almost there. Almost there. Tack. Yes. Good. So I'm going to start sharing my screen again. Right. So what I did is the following. So I first, well, I'm going to go from down to top after my error. So I created the notes concerning student. I created the notes by copy pasting, but into pieces. So we have 5 notes with 70 properties. Then I created the course notes with the name of the course. Well, I will describe them, or we will have a look at them and the result in a moment. So we have the creation of the courses, we have the creation of the rooms, and then the creation of the relations that connect the nodes among each other. Okay? So that's first thing to do. The thing is not actualized. I'm worried, but I'm going to do this. Yes, of course. This you don't do, huh? This is my little problem because I am early connected. So, right, you have your notes created. You see, I have mine. So I have person. I'm going to use the graphic interface first, so I can query my people. There are different people here that I have declared. I can also have a look at the projects, the rooms, and the students. Yes, please.
Teacher, could you send the page where you are copying the
It's on the chat.
chat? It's just that I can't see it.
You don't see it? Why don't you see it?
Oh, I can't either.
Okay, thank you.
Maybe
Because
I think it's because,
you went back and forth, and so you lose the history of messages. Is that right?
but I also think it's because it says they're moderators. So I think that's a chat exclusive to moderators.
All right, but you are all moderators, in fact.
I cannot see it. This chat.
I'm gonna copy again for everyone.
Yes, please.
So that at some point I declared you all moderator, so you can stop the session whenever you want. And now I need help because today is not my day. Yeah, right. Alright. And so we are all here, and that's the specification of the exercise, and I will share again the link to them to the manual. So that's the cipher manual. So you have both. When you go here to the exercise, what you have is the creation of the graph. Okay. So you have the students, where a student has a name. I'm going to profit to explain the properties of the node. Remember that in the jargon of graphs, nodes have properties. So because we are dealing with property graphs. So we have a node of type student that we name S1, and that has an ID, a last name, a first name, and a middle name. Okay, and like that, and note that some of them have middle name and some do not, and this is normal in NoSQL approaches, because in fact the set of properties is in fact a document that can have or not all the properties that we can associate to the nodes. So that's for students. Then for course, a course has a number and a title, so the name of the course. And note again that, well, since this is a property, there is no constraint about the numbers that I use. Okay, I do not even, and of course the numbers are all, it's like a document, it's like a JSON, so all the values of an attribute are strings, in fact. And then eventually we can convert them into numbers if we need that. So that's the courses. Then the projects have numbers. They have and they have also titles. And finally, the rooms. The rooms have different names. I think that well, it's like, well, at the lab we do not have names, but to auditoriums, but well, it's, I don't know, LI 123 or whatever. I do not longer remember if there is numbers in the buildings or not. That shows that I'm an old person. A very old ex-out lab. So that's for the nodes, and then for the relations, we also have types of relations: takes place in, enrolled in, works on, and so for the relation takes place, it is a course that takes place in a room. So for example, the course C1 takes place in room 1, etc. Then for the relationship enrolled in, you have that student S1 is enrolled in course S1, C1, sorry. And then for etc. And then for the projects, you have that student S1 works an hour in project 1. And the person, so the same student works 2 hours in project 2. And so on and so forth. Okay, so yes, please. Yes, Mauricio. Tell me everything.
Sorry, it's not me. It's in the chat. I left my hand
Your question.
raised. Yes.
Okay. You can't generate the graph. What is going on with the graph? Do you have like me problems with the quotes?
I think that I do.
Yeah, I'm going to share another document because the thing with the quotes in the in my what can I do? Yes, I'm going to do the file. I'm going to open a text edit, so new, and I'm going to copy this here, and I hope it will work. The problem is that when you copy paste, it transforms the quotes in a way, and so we are copying the wrong representation of the quotes. I have everything. No, I do not. Just 1 second, and I share the document. Let's see. And I will discover how to share documents. So, graph. And I don't want what I want to write here. It doesn't matter. Okay, so now I'm going to share this with you. I have had a busy day, as you can see. So, what is the graph? I know what I'm going to do. It's easier here. I'm going to put it on Slack, and then you get it from Slack. Oh, I love Slack. That's what I have. And so we'll have it there. Right. So you can go to Slack and retrieve the document I shared, and there I believe that you won't have problems with the quotations. So meanwhile, while you do this, I come back to my story. So in Neo4j, you can interact with the notes and have descriptions, and then you have, for example, here, if I click to this node randomly, I know that the ID of the node is of this student is 12, that she or he is Steen and Ber, no? And the student ID is 4. And so we can explore like that the node. So here we have a John Doe, student 3, etc. Please.
Oh, no, it's nothing. I just wanted to say that it did worked.
Excellent. That's good news. So in the same way that we can explore the nodes, we can also explore the relations. For example, takes place in. We know that alpha, the course alpha and Pascal, take place in. Sorry, I don't know what is this. This is a course, no? Oh no, this is a room. So Pascal is taught. Pascal, can you imagine this? Is taught in alpha, in the room alpha. This is a very old university. So of course that is a simple way of having a look at what we have created. There is somehow a set of comments that I want to do with respect to the creation of the graph. Of course, as you can see, at the end, once we have created all the graph, we have a kind of integrated structure where we have the instances of the nodes, and we have a sort of schema, no? The structure of the graph. What you well, for the time being, as you can see, we have directed relations. So we have a directed property graph. Yet in Neo4j, this is not the only graph, that type of graph that you can create. You can create an undirected graph. And you can also, for the time being, only in the case of projects, there is a number of hours, no, in the relationship. You can decide whether to label or not the relationships. And what is the best way of representing a set, well, the set of data, the situation that we are representing here. That's the big problem, okay? So deciding which is the best graph that can be used in order to represent a collection of data. Depends, of course, on the data, on the mini world that we are representing, but also on the type of queries we are going to ask. If you remember well, when you studied the relational solution, what you have in the specifications is that you have the mini world with a lot of this textual natural language description. And the big thing to go from the mini world into the entity relation, whatever model you used in order to represent entities and relations, was that what aspects of the mini world are represented as entities and what aspects are represented as relationships. Okay, so that was a first thing to be done when you were designing the database. Yes, Carlos.
Doctor, I just want to clarify. We have different graphs, you and us, right? Because I can see that you have like almost 3,000 entries, and I have
Yes.
16.
Yes, because I've been playing a lot with it, and you are just using this for the first time. No, do not try to cope. I don't know even if you have the nodes house house region. The
No, actually, we just have the nodes
nodes that
course,
you
project,
created.
room, and student.
Yes, yes. It is because I teach other versions of this course, and in that version we were doing graph analytics on another graph, and this is why I explained last time that suddenly when you start creating other graphs, you have a soup of nodes like me. That I have my little soup of the nodes that we are creating for this exercise, and others that I was using in another case. So you have this soup of nodes, and the only way of knowing and having an order is really exploring the graphs and the relations. So this is why I have other things, but do not worry about it. Okay, so when you do that, you well, it's like the intelligence of the designer of the database solution that determines the strategy to decide whether something is an entity, whether something is a relationship, and then the understanding of the meaning word where you define your constraints, etc. And another thing that you do during this specification stage is that you know more or less the type of the queries that you can ask on top of your schema. And then you design the relational scheme, blah, blah, a lot of things. No? In the case of graphs, what you will have is the data and you will have the queries. And what will decide what type of graph you are going to use in order to represent your data is defined by your queries. If your queries are interested in answering questions that imply that you need directed relationships, then you will adopt a directed graph, for example. If some of the queries ask, for example, for aspects that relate to possibility of labeling the relationships, then you will decide to have properties associated to the relationships. And this is a very complex decision making, to the point that in some systems, here we are really using the very simple version of Neo4j, but in some systems, the system lets you have different representations of graphs. You run your queries and you decide which graph you are finally going to keep according to the performance of execution of your queries, and of course, depending on whether you can express the required questions or not. Okay, so there is not a proper phase of designing the schema. As you can see, well, we are not going to see that here, but you can import a CSV file, for example, to Neo4j, and it creates a graph. Okay, so these kind of things it is possible to do, but then you have a first representation, a graph representation of your data, and then deciding whether this is the best or not requires querying, okay, in order to adjust and make sure that at the end you reach performance, which is again what we are looking for when we use NoSQL systems. So that's important to bear in mind with respect to graphs, and of course to the other types of NoSQL systems that we have addressed. Right. Comments or questions until here? So while you decide whether there are questions or not, now we go to the serious thing, which is asking queries. So for for expressing the queries, remember that well, in this time we more or less know how the graph looks like, and what we're going to do in Cypher is expressing patterns that we want to look for within the graph. Okay, so that's the principle of the situation. So what I'm going to do is, well, I'm going to read the first query. I'm going to stop sharing, and I will ask a volunteer to give a try on the expression of the query. Okay, so the first one is very simple. We are looking for the names of the available rooms. Okay, so I'm going to stop sharing this. What do you think? And then I give you some seconds to think about this, and we can discuss. So what are we looking for? We are looking for rooms. So we are looking for nodes of type room, and we want to see the value of the property name. That's the principle of the question. No, so remember that you have, well, the very simple expression of Cypher is having match, where you express the pattern that you are looking for, and then return, where you want to kind of project what you're looking for. In this case, we are looking for the name of the rooms that are available in our mini university. So I'm gonna give the first just to warm up the audience, and then I will
Doctor,
ask. Yes.
could it be possible that we do the first query together so
Yes,
that we
that's what
can...
I'm saying.
Okay, thank
That's
you.
exactly what I'm saying. So you have it on the chat. So we have match and we have return. Okay, so that's like select from. So now what the query says, I'm looking for the name of the rooms. Okay, all the rooms in this mini university. No, so I'm looking for nodes of type room, which is the first part of my match expression. Okay, so I have match, and I'm looking for nodes of type room with capital. No? And then I want to return, when it gets the room, I want to return only the value of the property room name of the node. So it's in the, if you want to reason mechanically, what it will do is it goes to every node it goes and see whether the node is of type room. If it is, it gets the corresponding property, blah, 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 until there are no longer nodes available. So this means that in my case, that I have a soup of nodes, it will go and have a look to all the nodes that I have in my soup. In your case, it will be very easy because you do not have a lot of nodes. So I let you try to see what we get. So if you execute the query, what you will see is this story that we discussed last session, that it's not a node, it's not a graph, okay? It is a set of strings with the name of the room, so it looks like a table with one column named as the name of the property, room name, and then you have the values of the name of the rooms. So you want to see, for those that might be having problems with connection or anything, because I see people coming back and forth, and this means that if you are having connection problems, then your poor Aurora is also having problems to connect. So my query is the one that I shared in the chat. I have match room. So room is an attribute that I give, okay, a name of the, and then of type room, and I return for every instance that it, so this is like a variable, no? So for every instance of node of type room, I navigate through the property room name, and I have my result.
So, doctor, in the query, when we are declaring room with a non-capital letter, what we are saying is that we are associating that word with the node's room.
We are creating a container, it's a variable.
So we could name it whatever we want.
Normally you could, yeah. Have a try, R or clase, or I don't know, sal, for example. But then you keep the same here, no? Right, more or less. It looks, well, it can get a little bit complex, but normally, yes, please, Mauricio.
Teacher, so it's just showing one room? Or
No, you're showing several. I have 4 rooms. I went through the set of rooms that we have defined. So we defined 4 nodes, and for every node, it got the value of the property room name.
okay, I see. Yeah, I got confused. Thank you.
You see?
Yes, yes.
And so it's Pascal, blah, blah, alpha, beta. So a nice exercise, if you want to play with it, is you reproduce, for example, the organization of rooms at UFLAB. So you create your graph, and then you start having a look at the different rooms. You can even, for example, think about how would you represent the fact that rooms are organized by building, no? So within one building, you have a room. So if you are representing this, whether you are creating nodes of type room, or a building, for example, or you decide to put a property building within the attributes of the room. You see, so that's a design question that you would have to think about if you were, for example, representing the way rooms are organized in our university. So, more questions? No questions? We can go to the next. Remember that at some point we'll need volunteers. I can do 2 or 3 at first so that you get acquainted with the principle, and then. So the second one is more or less the same. We are looking for the names of the current projects. So the first one was with rooms, and now we are exploring projects. And for example, we can ask to have the number of the project and the name of the project to make it more interesting. Do I have a question? I do. Okay, yes, a project return project. And add, please, Carlos, add the number of the project in your expression. You can add it, and if it's possible, you can share your screen and show us how does the result look like on Neo4j. Right. So if you can share your screen, please do, and we can see the result.
Doctor, I don't have permissions to share.
You don't have permissions to share. Well, that's a good thing to do. I always it's here, and right. I think that now you have. I'm going to turn everyone into presenter so that it does at some point you want to participate, you can. So tell us everything.
Well, as you said, the query was more or less almost the same as the previous one. So I named my variable project because of formality, and I associated with the notes project. I return every project name, and also I put a comma to add the projection of the project number. And this is the result. We have the
Right,
4 projects with their respective number.
with their number. Excellent. Right, questions? Everyone catches the bus? Good. So let's move to a more interesting thing to do. In which room do courses, not those courses, do courses labeled with number 1 take place? The idea is that you retrieve the name of the course, or you return the name of the course, the names of the rooms in which the course takes place. So meaning that the same course can take place in different rooms. So while you think, I'm going to define everyone as presenter. So just give me 1 second that I finish. Right, Mauricio Medina, and Nicholas. That's right. Okay, so what do we do here? So now we are involving a relationship. No? So the pattern becomes more complex because we want patterns where there is a course and there is rooms, and we're looking for courses that are related with rooms. And in addition, we are not looking for the rooms for any course. We have a restriction of value. We want to see course number 1. And then we want to project the course name and the room name. And here we have 2 alternatives. Who says I go for it? Yes, please.
I think I have it. Well, I don't know. I'm not sure.
No, I mean,
Do I
try
write it
and
or?
then we see. So you have rights to share your screen if you want, or you can put your answer on the chat. We see it, and then you show them its execution, the way you want to organize yourself.
Okay. Well, first, I think this. I don't have all the part, but I think is we first start like this.
Okay.
The return I am missing.
And why do we have student?
I know.
I think
Well,
that's the wrong question. You're in number 5, and we're in number 3.
oh yeah, yeah. I'm number 4.
He, number number 5. No, the one with the. So the question
Ah,
for
yes.
all.
Sorry,
Let's
that's right.
have a
Number 5. Yeah.
doesn't matter.
Okay.
Let's keep it. Okay. So for everyone, the question says, which students and how many hours do they work on the project with number 24? And we want to retrieve the name of the project, the last name of the student, and the corresponding number of hours that he or she works on the project. Okay, so what Jorge is proposing, I don't know if you prefer Jorge or Andre.
Both fine.
So, Andre, so we have, of course, match. So he says he's looking for, so it's a little bit incomplete, but it's a first try, okay? So first idea is, of course, that we are looking for nodes of type project. And yes, and then with the clause where, he is filtering the number 24. So until there, you are right. But then note that we are looking for students involved in projects. So we need to introduce the relationship works on.
Okay. Yes.
Okay, I will come back, Carlos, to 3. I will stay on 5, and then we go back to 3. So you are looking for any student. In fact, you are looking for anything that is connected with project, with the relationship works on. Okay, so you would have something like this. Well, I'm going to introduce even the thing that you have on the where. Okay, so the first part of the query, Andre, would look like that. So you have NES, any student, In fact, here in my approach, it's anything. Any node that it's connected with the relationship works on with project P, and where the number of the project is 24. So that's the first part of the, you were not far away, but what you were missing,
Okay.
in fact, is this idea of exhibiting the relationship. And that's normal because, in the relational case, we never exhibit that. This is automatic, by construction. But here we have to exhibit the relationship, in this case, the pattern with the relationship that we are looking for. Okay, so that's the first part, and then the second part, and well, you were missing the return part of the query. Every query
Yes.
must have a return, and so for the return that was easy because we were looking for this. No, we were looking for the name of the project that we already have here, the last name of the student, and the number of hours working, which is a label here of the relationship.
Okay.
So
Yes.
you are involving the properties of the relationship, the properties of both of the nodes that are connected through this relationship. And then, of course, you can use P project and then have the where close where project number is equal to 24. That's another possibility, as the one you were trying in your first expression, right?
Okay. Yes. Thank you.
You're welcome. Now we go for this is my try for number 3. So we have 2 tries for number 3. Let's compare them. That's nice. So Carlos was proposing to match a course where the number, using the clause where the number is 1, and returning course name, course number, and well, there were 2 course names. No, and the room name. Yes, the room name. Okay, so a problem, Carlos, with your try is that again you are missing the relationship. In fact, we are looking for the relationship takes place. Okay, so you have here, you need to have course, and you need somehow to involve room, because we are looking for the courses, the rooms where a course takes place. And so here you do not have, you did not consider the room. You are just obtaining the courses, the number of the course, and the name of the course. Here you are only giving the list of courses that are scheduled, for example, in this moment, right? And then we have another try by Mauricio, and Mauricio says that we are looking for course number 1, yes, that takes place in some room, and then we return the name of the course and the name of the room. Yeah, that's right. You see, well, in the case of Carlos, it was almost there, but you don't have to miss that in fact, in many cases, the relationships are involved in the queries. The first 2 were really very simple ones, but in fact, normally we play a lot with the relationships because we are doing traversals, in fact. But here, traversals are implemented in the backend of the Neo4j in this case, and we are just expressing them declaratively. But behind there is either of the 2 algorithms, the breadth first and the depth first algorithms in order to explore the graph. That's what happens in the vaccines. Let me see. Course room where course name is written. Yes, yes, and thank you, because now we have the two options. The one including the constraint in within the expression of the specification of the node, and in the case of Carlos, using the closeware. Both are correct. Questions from the audience? From the other audience? So good. So in the middle of these 3 and 5, we have question number 4. How many hours and which projects does students with does a student with student name 1 works on? And we want the name of the student, the project the student works on, and the corresponding number of hours. So this is more or less the same as number 5, but this time is with student. So who says I? Or me? No ideas? So I'm going to give the hint, because we still have 6, 7, and 8, which are a little bit more interesting. So up, this is my try. So we are looking for student. In fact, this is 1. Well, you change 1 and 2 into 1, because in the question is 1. So I'm looking for student with ID 1 or 2, some ID that works on some projects, and I want to retrieve his or her name, the name of the project, and the number of hours he or she invests in the project. So do not hesitate to go and have the try on Neo4j. I have this on one. So that was number 4. So I let you try on Neo4j. Okay. So number 6 is which students work in which projects and how many hours. So it's a variation, but a little bit more of challenge. We want the name of the students, the name of the projects they work on, and the corresponding number of hours, ordered by the last name of the students and giving a limit of results to 4. Here we, like we say in French, c'est la totale. So who says I volunteer for this?
Teacher, sorry, in which question are we?
We are in question 6.
Okay, thank you.
So who says hi? And have you seen in Neo4j that it has a nice completion of the types of query if we are exploring nodes, it proposes completion of the node, etc. So come on, guys, don't sleep. We are almost there.
I'm thinking in the answer.
I know. In fact, the match is very simple because we want associations, students with projects through the relationship works on. So that's first thing to do. No? And then in fact, there is almost no restrictions because we have last names, hours, and project name. And then the key part is the order by. Yes.
Actually, that was what I was going to
Yeah.
say.
Right.
I I have the first part of the query, but the
Mhm.
part of the sorting and the limitations is
Uh-huh.
the those things are the ones that are missing. The filtering, I think that I do already
You
have
have
it.
share please your expression in the chat and we can complete. So, right, you have students that work on projects, that's fine. You have the projection, and then the last part that you're missing is very simple. It's just remembering the following, that it is possible to order by last name,
Ah,
and
exacto,
then
lo iba a decir. Ah,
you see,
sorry, I had my phone.
no problem. You see? But that's, I mean, if you go to the manual and you have a look, you will see, and then you put it, and there's no rocket science behind it. The most important part you have. Now, if there are no comments with this, there's number 7. So these 8 questions are very simple questions, okay? So then I will send some more complex queries that you can address, and there, well, there's the second level. No? It's just warming up, and then we can have the second level. Which students work on, yes, work. So you have students that work on projects. The project, okay, and you order by name. So Carlos, that's the, yes, that's the number 6, that's right. Okay. And then number 7 and number 8, what we will do is, since we are running out of time and you have to think a little bit about them, because number 7 involves an aggregation. That's the number, and number 8 is a composition, it's a kind of join. So I will let you have a look at 7 and 8. And what we will do is you are going to share your tries on Slack. And I will comment these 7 and 8 on Slack. so that you can peacefully think on the possible answers, and we can discuss asynchronously about your ideas. Okay?
No problem.
Right. Excellent. So we are going to stop here. As I said, now we are going to discuss very specific details, technical details and algorithmical details tomorrow, in order to really close the topic, and then so that we can move into parallelization, which is also a very nice and challenging topic to address. So I let you finish these two questions, and then, as I said, tomorrow we will go to MVCC and Memcache and these kind of funky strategies that many systems adopt and that you should know. Very good. Questions of any type before we close the session? Please. Ian. What are you? You are Ian or you are Jan?
I'm Ian, teacher. Hi.
Okay,
Just
hi.
sure. I'm curious about if you are gonna upload the videos of classes in YouTube. I think that we need the next one that is uploaded to solve the sharding questions.
There is at least all the last week that is missing on YouTube, I believe.
We
I'm
have
not
until the 5th of February.
Okay, so when we finish the session, I will make sure that all the videos are there. If they are not there, this means that they are still on the Blackboard. Okay, so if you are really requiring something, go to the Blackboard. But anyway, I
Yeah.
will put them on
I check
YouTube, and I will
already.
send a message.
I check already, and there is no videos in. It's just one of the 11th February on
No,
the
don't tell me this.
on Blackboard. Yeah, but thank you so much.
Okay. Now I am scared. Okay, so have a look. There is one that I'm sure that will never be there because I forgot registering. But the others, I believe they should be there. Okay, so I will have a look and send again a little message on Slack to tell you what's there in YouTube when I put it there. Okay.
Okay,
Thank you for
thanks,
telling
teacher.
me. You're welcome. I really hope that the little blackboard didn't erase our things, but well, I hope it won't.
No, Blackboard does save the chat, so there's no
I
problem.
know, but I think that they having space problems.
Ah, okay, okay.
And so at some moment they pop.
Yeah, I
And
think
see,
every 2 weeks. I think every 2 weeks they get rid of.
they erase the history.
Yep.
So that's why I have to be like on to not to lose the videos. Okay, so I let you work on the use case too. Do not hesitate to ask questions. I've been having questions from some of your colleagues. So really, do if you want to discuss something, do not hesitate to contact me on Slack. And sometimes it takes a little bit because I'm busy or whatever, but normally I answer very fast. Good. So let's continue our day. Well, your day, because my day is almost finishing, and then see you tomorrow. Yes, please, Alexander.
Thank you, Doctor. Excuse me, I have questions, but regarding to well, one of the homeworks. It's regarding to the polyglot data management on the cloud.
Yes. What you can do is you can contact me on Slack. Depending on the question, we can decide whether I can solve your questions on Slack or we can um, schedule a Zoom or whatever in order to interact.
Thank you, Doctor. And also, because you mentioned at the beginning of the class that some activities were to be moved on the 23rd, I was wondering if this one would stay on the 20th or would it be moved on the 23rd?
The first two, the Mongo ones will stay on the 20th, and then the polyglot persistence will move to the 23rd.
All right. Thank you very much.
You're welcome.
Have a nice day.
Have a nice day too.